Welcome back, friends. In this video, we are going to derive Newton's second and third equations of motion. So let us start. Already, we have derived Newton's first equation of motion in the previous video. Those who are not watched the video, the link is given in the description box. You can watch. So let us start Newton's second equation of motion. Newton's second equation of motion gives the relationship between displacement and time. So from this velocity time graph, the distance covered by the object will be equal to area of quadrangle. We have already learned distance time graph, the area covered or the distance covered will be equal to area under the graph. So in this graph, the distance covered will be equal to area of quadrangle DOEB. Area of quadrangle can be divided into two geometrical shapes. First one is triangle DAB and rectangle DOEA. So the distance covered is denoted by the letter S. So instead of area of quadrangle, we can write area of rectangle DOEA plus area of triangle DAB. That is, S is equal to, what is area of a rectangle? Area of a rectangle, we know that it is length into breadth. So length is OE from the graph and breadth is AE. AE plus area of triangle, the formula is half into base into height. That is half into base. Base is from the graph, base is BA and height is AD. So we can write BA into AD is the height, AD. Okay. Now, substitute the value of this. S is equal to OE. OE will be equal to T. T into AE is equal to OD. That will be equal to initial velocity U plus half into BA. BA will be equal to CD. That will be equal to 80. We have derived in the first video in Newton's first equation of motion. And AD will be equal to OE. That will be equal to time T. Multiply and write. S is equal to U into T is UT plus half 80 into T is AT square. So we got S is equal to UT plus half AT square. This is Newton's second equation of motion, where U is the initial velocity, A is the acceleration, T is the time, and S is the distance covered by the object. Now let us derive Newton's third equation of motion. Newton's third equation of motion gives the relationship between displacement and velocity. Okay. We know that the distance covered by the object will be equal to area under the graph. That is area of quadrangle DOEB. Okay. That is equal to area of trapezium. DOEB is a trapezium in which DO and BE are the parallel sides. OE and DB are the non-parallel sides. And we know that area of a trapezium is equal to half into sum of parallel sides into height. Sum of parallel sides. Which are the parallel sides? OD and EB. So we can write half into OD plus EB into height. Height is AD. Height will be equal to AD. Now, substitute the values from the graph. That is half into OD plus EB. What is OD? Initial velocity U plus EB is equal to final velocity V into height AD. AD will be equal to OE from the graph. That is equal to T. Okay. Now, we know that from first equation of motion, we know V is equal to U plus AD. So from this equation, what is T is equal to? T is equal to V minus U upon A. Okay. So instead of T in the above equation, we can substitute V minus U upon A. So the above equation becomes S is equal to half into V plus U or U plus V into, instead of T, we can substitute V minus U upon A. On cross multiplying, we'll get 2AS is equal to V plus U into V minus U. Now, this equation, V plus U into V minus U, is in the form of identity A plus B into A minus B. What is A plus B into A minus B? That is equal to A square minus B square. So we can write this as 2AS is equal to V square minus U square. Now take U square to the other side and rearranging, we'll get V square is equal to U square plus 2AS. Okay. So we got V square is equal to U square plus 2AS. This equation is Newton's third equation of motion, which gives the relationship between displacement and velocity. This is Newton's third equation of motion. So we have derived all the three equations of motion. I hope you all understood. So thank you for watching the video. Please like, subscribe and share. So bye for today.